All right, today we are diving into something really cool, a new AI framework called Cosmos. And its whole goal is to build smarter AI by, get this, borrowing some of the best ideas from the most powerful computer we know of, the human brain.
But first, let's talk about a question that's been bugging a lot of people in AI. We have these models that are so powerful they can write code, they can write poetry, and yet they have this really weird blind spot. I mean, if AI is so smart, why is it so bad at noticing its own, sometimes really simple mistakes? Tackling that exact problem is what Cosmos is all about.
So, here's how we're going to break it down. We'll start with the next big hurdle for AI and see how the human mind actually gives us a pretty good blueprint for a solution. Then, we'll get into the Cosmos framework itself and its core thinking process, before we wrap up with why all of this could lead to much smarter and more adaptive AI systems.
So we're really at a turning point for AI. The big challenge right now isn't just about making an AI that's a little bit better at one specific thing. It's about creating a more general, adaptable intelligence that can actually handle brand new situations it has never ever seen before.
And here is the key difference that researchers have really zeroed in on. Today's AI models, they're actually pretty good at fixing a mistake, but only if you point it out to them. The real problem is they are terrible at monitoring for those errors on their own. They just don't have that self-awareness to notice something's wrong and adapt all by themselves. So, where do we even begin to look for a solution? Well, back to the human mind. Now, let's be super clear here. The idea behind Cosmos is not to create some kind of feeling, emotional, conscious AI. Not even close. It's all about borrowing nature's blueprint, mimicking the really powerful cognitive functions that our own consciousness gives us. It's an engineering approach. Okay, just think about being at a really loud party for a second. Your brain just automatically tunes out all the background noise so you can focus on the person you're talking to. Well, Cosmos proposes an AI version of this, something called perceptual curation. It's basically a filter inspired by our own attention that sifts through all the incoming data so the model doesn't get totally overwhelmed. It's about giving the AI focus. Another huge inspiration is our ability to think about our own thinking. Scientists call this metacognition. So Cosmos copies this by using a two-AI system. You have one AI that's doing the main task, and then you have a second supervisor AI that's just watching it, kind of managing its internal thought process. It's basically like giving the AI a manager for its own thoughts. And all of this brings us to the Cosmos framework itself. That stands for Consciousness-Oriented Self-Modifying Operating System, which, yeah, is a mouthful. But it's really a whole new architecture for trying to build more general and adaptable AI.
The whole philosophy behind Cosmos really rests on four main pillars. There's the dual model architecture, which we're about to get into. There's that metacognitive framework we just talked about. Then there's perceptual curation to keep it focused. And finally, this really fascinating idea of an evolving sense of self.
Let's break down that dual model thing. So the first part is what's called the self model. And this is not some static resume of what the AI can do. No. It's a dynamic understanding of its own identity and its role for the specific task at hand. This identity is basically a system prompt that is constantly being rewritten on the fly.
The other half of that architecture is the world model. And this is the AI's curated, focused view of its environment and the current task. So instead of just letting its context window get jammed with every single piece of information, it actively prunes it, shaping it to contain only what's truly relevant. It's all about avoiding that information overload.
Here's a really simple way to think about that dynamic self model. You probably act a bit differently at work than you do when you're hanging out at home, right? You just naturally adapt your persona to the situation. Well, a Cosmos agent does the exact same thing. It changes its persona to best fit whatever job it needs to do at that moment. So how does this all actually work together? Well, it happens in a continuous cycle that's really the engine of the whole system, the architect, plan, interact loop. This is literally how a Cosmos agent thinks, how it learns, and how it adapts in real time. This cycle has three main steps. First, you've got the architect. Think of it as the strategist. It filters all the data, it updates the AI's models, and it pulls up relevant memories. Next, the planner steps in. This is the CEO. It takes those updated models and creates an action plan. And finally, you have the interface, which is like the operations team. It goes out, executes the plan, interacts with the world, and gathers new data to start that whole loop all over again.
Okay, so we've seen how it works, but why does any of this actually matter? What's the big picture? Well, the end goal here is so much bigger. It's about creating AI that's smarter, more adaptive, and ultimately much better aligned with what we need it to do.
An architecture like this promises some pretty major advantages. For one, you get way better error detection because the system can actually notice when reality doesn't quite match what it was expecting. It also allows for real experiential learning over time. It promotes context-sensitive behavior, so it can adapt as the world around it changes. And all of that leads to better alignment, which just means creating AI systems that are more robust and more useful in the real world.
You know, the paper's conclusion really says it all. The goal isn't to create a feeling sentient machine. Instead, it's about a really practical engineering approach, about borrowing cognitive patterns to create systems that are more robust and versatile. At the end of the day, this is about a fundamental shift in how we build AI, moving from just making our models bigger to trying to make them genuinely smarter. So it kind of leaves you wondering, what's the next human cognitive trick you think AI needs to learn?